we're learning the basics of object-oriented programming. And so in contrast to what we've been doing so far, which is called the procedural paradigm, we will be using the object-oriented paradigm. So basically what we've been doing so far is we've been creating these procedures that operate on data. But what we're going to switch over to today is creating what are called objects, which will contain both the data that we want to operate on and the functionality that we need to write in our programs. And so oftentimes these objects correspond to real-world objects. And so I'm just going to open up a Python file so we can see an example. So far, when we have been writing our code, we write things like this. Like if I want to create a function to draw a square, so I might create a function to draw a square like this. I'm going to call it draw square, and I'm going to pass in a parameter my turtle t, and then I might say something like for I in range 4, I'm going to tell my turtle to move forward 50 units, and then I'll tell my turtle to turn left 90 degrees. And then now that I've defined this function, a sort of procedure that I would like my program to execute, now I might call my function draw square and pass in, say, I have created a turtle called Alex. And so maybe I won't do this because this is just trying to get the idea here. So this is an example of a sort of procedural programming form of my program here, where my goal is to draw a square, and I sort of create some instructions, and I say, now I pass in my turtle Alex, and I say, follow these instructions. On the other hand, an object-oriented way to do this is actually to, within the object, the turtle object Alex, would be to do something like alex.drawSquare. And here, I'm not going to show how drawSquare is implemented yet, and we'll talk about that for the rest of the class. The idea here is that sort of rather than having this external procedure that sort of uses this turtle to create the square, instead the turtle knows how to draw a square, and we just call that method. And so we've actually seen this a lot. In fact, you might note that, well, aren't we using an object-oriented sort of syntax here when we say this turtle needs to go forward 50? And indeed, this is an object-oriented way of telling our turtle to move forward 50 units. And we've also seen this with strings and dictionaries. So, for example, if I create a string to reverse, and I call it example string, and I say something like example string dot reverse. Perhaps it does not have a reverse method. That is okay. We can do it definitely has how about we do an example list? Example list is going to be the list of 1, 2, 3. And that we can definitely reverse. So if I say example list dot reverse, now, so you could imagine if I wanted to do this in a procedural fashion, I might have to have some external function and call that function on my example list. And so I would say something like reversed list is example list of, or is reverse of example list. So this might be a procedural way of doing the same thing, but in an object-oriented paradigm, example list is an object. It holds the data, so the data is this list here, and it also has functionality built in, and that's why we're able to call this reverse method. And then if we take a look at example list, we see that it has been reversed. And so we have actually been working with this object orientation for a while now, but now we're just making it explicit, and we're going to actually see how we can define our own objects and how that can be useful when we're programming. Are there any questions so far on big ideas of object-oriented programming versus procedural programming, what we've seen so far? Feeling good? Okay, great. So in general, when we create objects or use built-in Python objects, they have two things. So they have state, and so, for example, a turtle object does anybody remember any of the sort of attributes that our turtles could have that we could change? So, size? Yeah, actually size is one. So we had size. So if you remember, we could set the size, but of course our turtle also came with a default size. Remember, like there's a default size for how big it's going to draw when it walks along, or how big the turtle is if we allow it to be shown. But we can change that. Any other ones? Yeah, shape. There was also color. I believe heading was one that we could change. We could either explicitly say what the heading was going to be, or if we call left or right with a number of degrees, that would change the heading. Speed. Yeah, speed's another one. And so our turtle objects are actually pretty complicated, and they have many, many different parameters, different attributes that define their state. We'll start with creating objects that have fewer than these, but we can make our objects as complex as we need them to be. The other thing that objects have are called methods, and these are the functionality that the object is able to execute. And so for the turtle object, any ideas? Remember the methods that we had that we could call? Yeah, so we saw in our example this morning, we've got forward, that moves the turtle forward. Any other? Yeah, so there's lots of left, right, up. Some other ones, I'm not positive what the syntax was, but there are some that were things like get color or get heading. Maybe we'll just say get color. And what these methods do is actually allow us to see what is the current color, right? So when I call get color, I'm not changing the state of my turtle, but instead I'm returning back some information about my turtle. There are also methods like set color, where we were able to change the color of our turtle. And so today what we're going to go through is an example of actually defining our own objects. And how we do this is we'll start off just with the syntax.
The methods, though, those need to be defined at some point as with like a procedural
Mhm.
thing.
Yeah, so the question of like, aren't these kind of mixed? And the answer is yes. Um, so yeah, like, oh, we close it. Well, so how about we'll address that like the question of like, is it procedural as we're defining our objects as we go? How about? But just like in the example, like I showed that example of, well, when we create our draw square function, we're actually passing in a turtle object, right? So there we're kind of mixing object-oriented programming and procedural programming. And so, at least for us in this class, and I think in general, there is often a mix of sort of procedural programming and object-oriented programming, but we do call it object-oriented programming when we are defining these classes and then writing just simple procedures that use those classes and use the objects. And the objects are sort of the place where the logic and the hard work of our program is. And procedures we use procedures just to do sort of simple things to use those objects. So what we're going to do today is we're going to define a point class. And let's see here, just have, okay. And so the syntax of so a class is actually sort of how we create these objects ourselves. So if I want to be able to create points in general, just like we can create many different turtles, we can create many different lists. If I want to be able to create my own object called a point, I do not use def. I use the keyword class, and then point doesn't take in any parameters because it's a class, not a function. And I'm just going to give it a little doc string, just like I could give a function a doc string. A point class for representing and manipulating points. So these doc strings are very useful for documenting our code, and also they will come up, be available in, for example, idle when we are using this point class later. So if we want to create a point class, let's see. Let's first think about what we want our point object to be able to accomplish. So this is like a 2D point in 2D space. So can anybody tell me some things that we might want to store in the state of our point? So this is going to be how we store and manipulate just points in space. Yeah, sure. So we might have, so the idea there is, so we might want to be able to, so like, I'll just put a star. We want to make sure that we're able to create a point at 0, 0, right? And so let's just note that and make sure that we're able to do that. So if we think back to like, our turtles had things like their heading, their color, and so these describe the current state of the turtle. What might be a similar idea for a point? Yeah. So we might have our x-coordinate and our y-coordinate. so now we know we don't have necessarily a way to set our point to 0, 0 yet, but at least we know that it could store that. We could create a point at 0, 0, right? Because we have an x coordinate and a y coordinate. Any other ideas about thoughts about, what could our point state be? Attributes of a point. They can be anything. Yeah, so that, like, does it have a coordinate that's positive or negative, do you mean?
Well, I guess can your x be just like -1?
Yeah.
Would it have to have a separate state set?
We're gonna say, let's say that we're gonna make this a float. So in general, when we make our points, we're going to say that we're going to expect that our x coordinate is a float and our y coordinate is a float. So it could be any number. So now we can describe points in the plane, things I could imagine us doing, and we're not going to do this today, but if we're just thinking, if we wanted to draw these, maybe these could have color. They could have any other information we wanted. So when we are creating our own objects, we get to define what attributes they're going to have. But for today, we'll just store the position of our points. So we talked about this ability to create a point at 0, 0. We could make a method that does that, but for now, some ideas for methods that we might want to be able to set our x, right? Or set our y. Say we have a point and we want to change it. And similar to the turtles that we were creating, we might want to just be able to check, like, what is the x coordinate and what is the y coordinate. And so we'll start off by taking a look at just a very simple point object that's going to have an xy coordinate, and it's also going to have an ability to tell us what is its x and what is its y. So when we create a class, which is sort of instructions for the computer about how to create a point, the first thing we need to do is create what's called a constructor or an initialization method. And we always pass a parameter into this that's going to keep track of the object state. And in general, in Python, you will notice that it's always called self. There's actually no reason why this parameter has to be called self, but just since you're always going to see it called self, you probably want to just call it self. And so what this constructor method's going to do is it's going to create a new point, and for now, let's actually have this point created at the origin. Create a new point at the origin. And so what we're going to do is, as soon as we create this point, what we're going to do is we're going to assign its x coordinate. Let's just call that x to 0. And we're also going to assign its y coordinate. We'll call it y to 0. And so what this is sort of I think these end up getting called magic methods that have this funny syntax. And the reason that they're magic is that even though I called this init inside my class creation here, when I actually want to call this method, how I call it is just with the name of my class. And so if I want to make a new point, let's say I call it P. If I just say P equals point and put some empty parentheses here, what this is doing is it's actually calling my constructor that constructs a brand new point and running whatever I put in here. And so I can make another point, Q. I'm just going to run this and we'll see. So nothing was actually output, but we did actually create a point P and a point Q. I'm just going to put some print statements in here and we can just examine what happens. So at the very least, we get some confirmation that something happened, and indeed we created a point object. And what this print statement is doing is it's actually just telling us what is the sort of like memory location of our point that we've created. We can change this print functionality later, but for now the default just tells us what's the memory location. And I want to point out that we actually have used constructors before. So if we recall when we created turtles, like if I say Alex equals, and we would import turtle, so we would say something like import turtle, and then we would say something like Alex equals turtle dot turtle with a capital T. And so what this is doing is it's saying, looking inside the file called turtle, find the class turtle, the definition of the class, and call its constructor method. Yeah.
So before I get too lost, is
Yeah.
the P and Q, are they the same thing right now?
That is a really good question, and we will talk about sort of like sameness later because it actually gets kind of confusing. But they are the same in that they're both points at the origin. They're both points that have like 0, 0. The data like associated with each of them is just 0, 0. But they are different objects in the same way that if we come over and we create two lists, like, so I have my example list. Oh, no, I don't. So if I have list 1 and I create, and it's 1, 2, 3, and then I make list 2, and I say 1, 2, 3. So I can say something like, is list 1 equal to list 2? And I'm just going to make this up higher so maybe it's easier to see for everyone. So if I ask something like, is list 1 equal to list 2? The way that these objects are defined, this will return to me true. But if I say something like, is list 1 the same, like, is it the same object as list 2? I will get false because these actually are two separate objects. Whereas if I say list 3 equals list 1, now what I've done is list 3 is just a pointer to list 1. And so let me ask, is list 3 list 1? And this, I'll get true. And so in Python, and I guess in programming in general, this idea of like the object existing and then the data of the object, and are those the same, will come up over and over again. And we'll actually get into more detail on that tomorrow. But that's a good question. And so the answer is sort of, are P and Q the same? Well, they have the same coordinates, but and they are instances of the same class, So they're both instances of the point class. So that's what we call when we create multiple objects from the same class, we call them instances, but they are different objects. They sort of live in a different place in our computer, and we can manipulate them separately. Whereas if they are the same object, then if we manipulate one, then we manipulate the other. But it's something we'll come back to. Yeah.
Is the init function is there something special about like underscore underscore init underscore underscore? Like, well, when you call p and create a new object of that class,
Mhm.
is there something that like says go look for this specific
Yeah.
function? So if I want like a bunch of parameters to be initialized, I would have to have it all into that, or do you have like multiple init?
Yeah, so it does know to look for the underscore underscore init underscore underscore method, and that's your constructor. And so if you wanted, if you wanted to say, I also have this color parameter and it's initialized to the string black, and I have also, random info that's just like stored here, and I have a list of, and so there can actually be more complicated classes, I believe, that have multiple sort of different ways to initialize. But for now, we'll just stick to, you have one constructor, and the reason we call this, I'm going to call it a magic method. Magic, I'll say constructor method. Whoop. Because it does have this special syntax, and what that special syntax translates into is we call it just by using the name of the class. Magic constructor method is always init, and then we put in our parameters here. So I'm actually going to move this over to the Python Tutor visualizer, and we can just see if we get some more insight here. So I've just taken that same code from before, and now let's just step through it and see what happens. Oops. Just gonna make this fit. Okay, great. So after we run our first line of code, we see that in our global frame, we have a point class that has, what does it know? Well, it knows how to initialize itself. So it knows about a constructor method, but nothing else. And then if we actually run, say, this line right here, by pressing forward here, we see that we have, so as we step through, try and make it so that we can see what's actually happening. Okay, so let me go to, so when I run this line, it calls this constructor method and that's because I specifically said point. And what happens in the constructor method? Well, we set self.x to 0 and self.y to 0. And we have no return, so we move on. Now we call it again, and we create another instance of our point class, q. So again, we're going to jump into our constructor method, and what this does is it creates another instance of our point class called q. So just to be very explicit about what is actually going on when we call that constructor method. So if we think of this, our class here, as sort of like the instructions for creating points in general, our constructor is like making a point with like the factory settings. And so one way we could define our point is to always create a new point at the origin. But another thing we could do is we could make it so that we can pass in our initial x value and our initial y value. And so now what we're going to do is we're actually going to create a new point at, let's say, the specified coordinates. And what do we need to do to change this to make that happen? Well, we're just going to set our x and y parameters to whatever we get passed. So I'm going to say, now let's try creating a point at 7, 6, and a point at -1, 1.5, for example. And so if I run this, again, I'm not actually showing anything on the screen when I create them because all we're doing is creating these instances P and Q, but what they actually have is different coordinates. And you might notice, well, why isn't, when I print P and I print Q, why is it that I'm still getting this same sort of looking output where I don't see that it's, I know that this point is at 7, 6, right? Like, why am I not seeing that? And that's just because I haven't defined my print yet. And so it's just giving me a default print that just tells me what kind of object is it and where is its memory location. But now we have this useful way that we can actually create points at different locations. So if we want, like we said, sort of a basic functionality that our points might have, we can create them. But now what happens if we want to see where is my point? So I can do that by creating a method. I'm going to call it getX. Could have called it whatever I wanted because I am creating this point class. And all this is going to do is it's going to give me back my current position. And so as I'm creating these methods, I always have to pass in this self parameter. And that's because if I don't pass this in, Python doesn't have any way to keep track of the state of my object. And so let's actually test this out. Let's print p.getX. But you'll notice that when I call getX, I don't put that self parameter in. And that's because it's sort of automatically done by Python. Oh yeah, okay, print. And then let's do it with Q as well. Q.getX. And so now I'm going to remove those print statements and run this, and we'll see if we successfully implemented getX. So indeed, let's see, what did I say? I said for P, I passed in 7 for my initial x, and when I say getX, I do get 7 back, and for my second point, same thing, pass in -1, and I do get it back. Okay, so if I want to also define getY, can anybody tell me, I'm going to have self, what statement should I put here to implement my getY method? Yeah, just return that y coordinate information. And so if I save this, maybe I'm going to also print p.getY and also print q.getY. And we'll just get right back. Well, we created this point at 7, 6, another one at -1.5, one, -1, 1.5, and we'll just get those right back. And if we were to exclude this self parameter, so first off, we can kind of see like, well, this function doesn't know about the self variable, so that kind of clues us in that we need to include that. But also, if I try to run this, the error that I get can also kind of clue me in as to the fact that I need to include that. So I'm seeing get y takes 0 positional arguments, but 1 was given. And this is kind of a confusing error, I think. But what it's telling you is that Python will always pass the self variable into your methods automatically. And so when it's saying 1 was given, you might be like, but no, clearly I didn't give it 1, right? Like that get y, there's nothing in there, right? But Python automatically passes that in, and so that's why I'm getting this error. And so if you're defining your classes and you're getting an error like this and you're confused, you're like, but no, those numbers match. One thing to always look for is, did I remember to pass in self? And another thing we could look at is, okay, what if I do remember to pass in self, but then I try to just return y? Well, what's going to happen here? It's going to say, I don't know about y, and the reason for that is that it's actually self.y, not just y. So now that we have this point object, we might want to do some stuff with it. And just like with objects, the built-in objects that we've been using all along with Python, we can define functions that use these objects. So one idea is we might want to define, for example, let's create a function to compute the distance between 2 point objects. So this is just going to be a procedural bit of code here that we will create, and let's call it distance between 2 points. And let's say this function takes in 2 parameters, p1 and p2. And I'm just going to say p1, p2 are point objects. So if I want to compute the distance between 2 points in general, does anybody remember actually, as a warm-up to this, we're going to get to this in a second, but I skipped over a nice, I think, warm-up. We know how to do this code, but just as a nice little like warm-up of like what's the algorithm to make this happen. Let's define one more method for our point class, and let's call it distance from origin. And so this is just going to operate on 1 point. We'll give it a docstring, and this will get the distance from this point object, this capital P point object, to the origin. So my point, it has a position x, a position y. Can anybody tell me how I compute the distance from a point to the origin, which is the point 0, 0? 0, 0. Not in code, just like in English. We'll put a comment in. How? Yeah. Yeah. So if the square root of the square of, yeah. Yeah, so in general, like the distance formula between 2 points, this is how I remember it, but the distance formula is just if I have point, x. If I have point 1 is x1, x2, and or x1. Excuse me. I'll call them x1, y1. I have some other point over here, x2, y2. There in space, wherever they are. If I want to compute the distance between them, I can say x1 minus x2 squared plus y1 minus y2 squared, and then take the square root. So this will always give me a positive value because even if this was negative, when it gets squared, it becomes positive. Same thing over here. And so if if x2 and y2 are 0, then that becomes, we just want to take the square root of x1 squared plus x2 squared. That's our formula. So if we want, that's what we want to return, right? In the end, we're going to say return something, return this, right? Formula for distance to origin. So our goal is to return this. Now, given the methods that we've already defined for our functions and the information we have, or the methods that we have for our point class and the information about our point class, any ideas about how we actually do this? So in my mind, you could think, okay, do I need to use my getX and getY methods? But actually, since this is happening inside the point itself, we can just reference those self.x and self.y, right? So if I want to return the square root of x squared, I'm sorry, I did this. Maybe this should be y1 squared. So the syntax here that I can use, I'm just translating what we had into Python from sort of maybe math characters. So if I want to square my x value, well, I can just get that by calling self.x. And if I remember, my exponentiation operator is 2 stars. And I can also call self.y, again using my exponentiation operators. And there could be many ways to get my square root here. I could import the math module, but to avoid doing that, I'll just use my exponentiation, just remembering that the square root is the same as raising to the power of 1/2. Remember, square root is raising to the power 1/2. And so, okay. And so what this should do is just compute that distance and return it to me. And so if I actually want to call this method, let's say I want to call it on P, any ideas about what the syntax might be after seeing how turtles work and how strings and lists objects call their own methods? Any guesses about how we got getX and getY? How am I going to call this method if I actually want to, say, print it to the screen when I run this program? I'm going to say print of P dot, and then what am I going to do? Any guesses? Yeah, distance from origin. And I don't need to pass it anything because this self is just implied and passed into the function by Python. And so maybe I will also print q.distance from origin. We can test it out on 2 different points here. And if we think about the 0.76. To me, I would say 9.2 seems reasonable about how far it is from the origin, and 1.8 also sounds pretty reasonable about the point -1, 1.5. But are there any questions about this distance from origin method that we've created for our points? So now all our points any point we make knows how to compute its distance from origin. Any questions about how we did that? Yep. Cool. So now we can move on to this idea that, okay, we have these points. If we want to incorporate these into a larger program, we will still be wanting to sort of execute procedures on them. One thing we might want to do is not just ask, hey point, how far are you from origin? But we might want to do something like create a function, distance between points. It's going to take in 2 point objects. And so I'll give it a docstring. Computes the distance between 2 point objects. I'm going to capitalize this P just to be really precise. And so it's sort of extending the idea that we used in distance from origin. What's our formula here going to be? What are we going to need to compute? Yeah, so we're going to use the formula for distance, so that's going to be the square root of, we'll say p1x minus p2x. We're going to square that. We're going to add that to p1y minus p2y. We're going to square that. And then overall, we're going to take the square root of that. So now when I'm creating this function that's sort of independent from the definition of P1 and P2, let's say I'm going to need to get P1x, P2x, P1y, and P2y. Can anybody tell me what syntax am I going to use to actually get this value from my points? Yeah, and why do you say that? Yeah, so since P1 is a point object, exactly right, it has that method. Why can I not say something like, self.x or something like that, like I did up here? Yeah, when I'm actually using these point objects, I don't get to access their sort of internal state. What I do get to access is their methods. And so what I need to do here is say p1.getX. And so I can just use that same idea to fill in the rest of this data that I need. So I'm going to say p2.getX. For my y's, I just have p1.getY and p2.getY. And now I have all this data that I need. And so, again, I can just return, let's say, I can actually copy all of this that I wrote up there, except I need to change my exponentiation to Python language, translate here, and then again I'm going to use my exponentiation instead of the math.square root. And so if I want to actually call this to test it out, well, let's try printing distance between points of P1. And what our points actually that we've created are not P1 and P2, they are P and Q. So P is still a point that I created up here. Q is still that point that I created up there. Maybe I'll just print the distance between the points is, and then on a new line, I'll print out the distance. And we'll see if this runs. Get X, looks like I did not capitalize. Unsurprising that there was an error in there. All right, and so we're getting a distance of 9.18 or so, which to me makes sense, but maybe if I wanted to test this, I could do something like, what's the distance I know? Well, I know the distance between the point 1, 0 and this is just something that I might do as I'm developing my program. If I create a point 1, 0 and a point 0, 0, what should the distance between these 2 points be? Yeah, and so if I just try test point 1, test point 2, and I'm expecting this to be 1, and it is 1, so here I have some evidence that I didn't make any mistakes, and my function, distance between 2 points, is doing what I expect, and probably then my get x and get y are also doing what I expect. So this is just something that I do as I'm developing sort of more complicated programs, is try to test things as you go. It's a good way to catch errors before they turn into big errors. So I'll just put P and Q back in here. So the important thing that we just saw is that even though the syntax for defining these methods is the same as the syntax for defining functions, they're not the same, right? Like this distance between 2 points is not a method of the point class. It's a function that we've defined that we could use outside of the point class. And another hint that we have that that's the case is we see this sort of procedural syntax here where we have a function with distance between points and we're passing in our point objects versus if this were an object-oriented sort of implementation of distance between points, it would look something like p.distance to q if I implemented it that way. And that would be an object-oriented way of implementing this idea of computing the distance between 2 points. Are there any questions thus far?
So
Yeah.
you're using like self.y, self.x.
Yeah, if we come up to the class definition.
Is there a way to add, like that's a built-in Python method?
Yeah, so this idea of like passing around this self variable is like a Python thing. And so we could call it something else, like state variables is something we could call it. And I'm just going to replace everything if I can. So everywhere where I said state before, or where I said self, I'm now calling state variables because what this does is it holds like the state of the object and, return self.x, state variables.x. So everything works the same. So if you have experience programming in other languages, you probably are not passing around this self variable, I'm going to change it back to self just because it's how you're always going to see it. So in other languages, even though there is this idea of an object having a state, it might not be implemented using this self variable, but that's what that is doing, and it can kind of feel a little unnatural, like why exactly is this? Why do I need to use this exactly? And yeah, it's to keep track of the state, and different languages might do it differently, but that's what's going on.
So the dot y and dot x after that, if you needed to add something that wasn't like built into Python, is there a way to do that?
What do you mean by wasn't built into Python?
I don't really see where you're getting the dot x.
So in terms of like this dot notation, yeah, that is like sort of like built into Python thing where this like state variable that we're passing around just has like kind of, we'll call it like special abilities, like, you know, this is like the magic constructor method, and this is kind of like a special variable. And so one thing that you can do is, like, let's say I want to do something like, I think this will work. We will try it out. So you can actually add parameters later on. So if I wanted to add something like, okay, not every point's going to have a color. So let's just check that this works. My guess is that in Python you could say something like self.color equals color. This would work. But let's actually try it out, because then let's call it. Let's say, okay, we don't need our test points anymore. Let's say something like p dot set color. So we said set color, and we're going to pass in a color. The thing is, this doesn't even have to be a color. Let's call it 6, string 6. So in Python, you can always add these state variables at any time. Like, oftentimes you create them all when you create your point initially, create your object initially, but you can actually have these state variables later. But the important thing is the only way to like pass around the state of the object is with the self variable. And so that's why anything that you want to be like a fixed thing about your object has to be referenced as self dot something. So if I just said color, you know, this point color, I might think, oh, you know, I called it this point color, so, and it's in the method of the point. But if I do something like this, I'll put a comment here, does not save color in the state of the point. Like this variable, this point color, is going to go away, and my point won't know what color it is. So.
Is there a way? So basically, all points in this class you have to create one. You have to give it an init x and y.
Is it? Yeah, there is. And I think Python does a really nice job of, or I like the way that Python does the default values for these parameters. And the way that you do it is when you define your constructor, if you put not just this variable in it, but you also put an equal sign, and then whatever you wanted to initialize it at as a default, then that will be the default. So let's, instead of calculating the distance from origin, let's make another point r, except let's call it with no parameters. So if I call my constructor with no parameters, then what am I going to do? Well, it's just going to set these to equal to 0. So now if I print r and I run this, oh, I forgot, r.get x and r.get y. So that's going to give me back what are x and y for r, and just like we wanted, it's 0, 0. And you can actually do these like default parameters for any function, not just the constructor. But if you want to know more about that, we can talk about it after class. So you can have defaults here if you want, in a really like slick way. Great. So we've already seen that, you know, if I go back to printing r here, like, and maybe I'm not going to print the distance anymore, just to make this a little cleaner. So if I run this and I print out I call print on my point r, I don't get anything descriptive that is super useful to me. And so what I might want to do is, I'm going to delete set color because we don't need it. I might want to be able to override that functionality. And how I do that is with another magic method here, magic method to override print. So if I want to, instead of just printing the memory location of my point r, I can actually just I can override the built-in method, is what it's called. Okay, let's say magic method to override, I'm going to say built-in print method, just to be really precise. And how I do that, just like I had to say underscore underscore init to make my constructor. If I want to call print and have it do whatever I define, I have to say underscore underscore str underscore underscore. And here, let's say I want to return like x equals, okay, I'm going to say for point with self dot x equals 4, self dot x equals 5 should return x equals 4, comma, y equals 5. So what do I need to put into my return statement here if I want this to happen? So we need to build up a string here. So first I want my string to start off with x equals, and then if I use string concatenation, what do I need to put next? Yeah, if I just put self.x, and then if I concatenate with another string, which is just going to be my y equals, and then I can concatenate to self.y, or concatenate self.y onto here. What this is going to do is return me a string that will then be printed to the screen. So let's try this out and see if it worked. Oh, must be string not int. I also forgot about that, so let's remember when we created our point object, self.x and self.y were integers or maybe floats. So let's cast them to strings. And since r was our point that we just had the default, we see that print indeed has been rewritten to print out x equals 0, y equals 0. Let's just go ahead and print our other points. Print p, print q, and we'll run this. And we see that p and q that we created, and we're actually able to print those out. So when we want to override our built-in print method, we use this sort of magic method here. Any thoughts about like why is this str instead of like it could have been something like, you know, underscore underscore print. Any thoughts? Well, I just think of it as like, well, I'm not like calling print here. You know, I could have said something like, oh, print this string, but I don't need to print it. I actually need to return it. And so what this method needs to do is it needs to actually return the string that should be printed. So I don't know. That just helps me remember it. So I thought I'd mention it. The last thing, well, second to last thing that we're going to talk about today is the fact that these methods that we're making can actually return objects as well. So methods can return objects. And so we'll create an example of one of these. And we'll call it halfway. And we always have to pass in self. So we'll do that. But then what's halfway going to do? Well, it's going to return us a point that's halfway between the point that we're operating on, that's calling the method, and some other point. So let's give it a docstring, return a point that is halfway between this point and a target. I guess we'll say a target point object. Point object, other point. So how am I going to do this? Like overall, what am I gonna need to return? Just in English, like what kind of thing am I gonna need to return? Yeah, so I'm gonna return a point, and how do I do that? What's the syntax for creating a point? Yeah, so we've seen like when we created this point, P, we had to use, in order to call the constructor, the init, we used just the name of the class. And so we can actually use that inside a method here. So what we're going to do is in the end, we're going to want to return some point, and maybe we can see that since we've got our docstring, that we're getting this hint about, oh, what is a point? Well, a point is a point class for representing points and manipulating them. So maybe let's just say we're going to define a variable that's new x and new y, because when we create these points, we have to pass in an x and a y unless we want it to be just at 0, 0. So now we're going to have to create our new x and our new y, right? So how are we gonna create our new x? New x will be, any thoughts?
The difference between self and the new point.
Yeah, so yeah, I mean, this is honestly, it's early morning, so it's hard to think through these things, but just to give, if this was me and I had to figure this out, I would probably draw a picture. So I've got my point, and there's some other point out there, and my goal is, maybe if I were to draw this, my goal is to return halfway point. And so it turns out that if I maybe just think of the x values, this x right here is kind of just like the average between the two x's that I have, right? So my x value of this will just be sort of the average between point 1 and point 2. So point 1, p1x, say, plus p2x, and I'm just going to divide that by 2. And my y value for this one, again, is just the average between the two y's. So it's going to be p1y plus p2y over 2. And that is how I can find the halfway points. So new x will be, I'm just going to say average of this point and other point x. And I'm going to say new y will be average of this point and other point y. So how do I compute those? Well, so for this point, the way that I can get how can I get the x value of this point? Yeah, so if I say self.x, I get the value of this point, and how do I get the value of the other point? Yeah, I have to say other point, other underscore point dot get x, because the other point is just an object that this method is taking in. It's not the point that this point doesn't know about the other point. And then I'm just going to divide that by 2. Similarly for the y, for this point I can do self.y, but for the other point I'm going to need to call get y. And now I have my new x and my new y, and so hopefully this will run and we can see, maybe we're going to do something like print, and let's do our syntax here. Let's say we want to do halfway between p and q. We could either do p dot halfway of q, and that should be the same as q dot halfway of p, right? So let's just try it out and see if we succeeded. And to me, these seem reasonable. Our original points were 7, 6, and we had 7, 6. This is p. Then we had -1, 1.5 was q, and what are we getting? We're getting that halfway is 3, 3.75, something like there. So that seems to me like evidence that we probably got that right. And so I think the big takeaway here is, like, if you think you might need to do something, you probably can do it. And when we're using a class to define our own objects, we have all the freedom we could want. But what we want to be doing is sort of defining the functionality that objects need to use. And it often helps to make this functionality sort of like follow like real world concepts or like even real world like objects in order to make your programs work. And this helps, like the reason why we have object-oriented programming and why it's kind of the most common way that software is developed is it allows like big complex software projects to be kind of comprehensible, and that's why we use object-oriented programming. Are there any questions about all that? New big ideas and also new syntax that we learned today.
When you're naming functions within the class, does it have to be in that format of like having the uppercase or all in words, or is that just kind of personal preference?
Personal preference. Yeah, you noticed that like in my method I was using the what's called camel case, so can name methods exactly the same as sort of like functions and variables that we saw. We can't start with a number, but otherwise sort of anything goes. And so just different people will prefer camel case, which is when we start with a lowercase, and then for every word we capitalize the start of the word, and it's called camel case because it's like it has humps. Another thing you can do is use underscores, but either would work, so we don't.
I just wondered, since outside of it you switched to
Yeah.
underscores.
Yeah, and the only reason that I did that is because this is an example from the book, and the book uses camel case, and I personally don't use camel case. I think this is called snake case when you tend to use underscores between words. So I usually use snake case, and the book uses camel case, but yeah, that's good pattern noticing. Any other questions? No? Okay. Great. So the last thing is that when you're defining your own objects using classes sort of in the real world, it's pretty common to split your class definition off into its own file, just for organizational purposes, so that we don't get, you notice that I had to keep kind of like scrolling to the bottom to actually create my objects and do tests on them, or maybe if I actually needed to accomplish something with this program, it could get kind of clunky to have this really long file, and if I needed other classes, it could be super long. So the usual way that this is done is for my point class, I'm actually going to have a file. So maybe I'll keep this file and I'll call it point.py. Again, it's pretty common to call, if you have a file that contains a point class, it's common to call that file point.py. So I'm actually going to move everything that's not my class definition into a new file. So I'm just going to say Control X to cut, and I'm going to create a new file, and I'm just going to paste all of this. And so what's this file going to be? This is going to be sort of where I run a program to manipulate that, that creates and manipulates point objects. And maybe I'll just save this as manipulate points.py. And so this is sort of like the command center of my program. Even though I need those definitions, they live in another file. And so as long as that points.py file is in the same directory as this program, if I use the import command, I say import point, that is how I access how I access my definition. And so here, just like with the turtles, I'm just going to have to say oh, you want to create a point? Well, look in the point file, which I've told you is called point, and call that constructor. And so let's see if I'm going to need to change anything else. I don't think so. So I'm just going to try running this, and we can see if it works. And did I leave? I'm noticing that I printed this 4 times, which I did not expect. And so I'm just going to see if I happen to leave anything in here. Maybe I didn't save this before running it. And then I'm going to go check over here and run it again. Because So I'm able to import everything that was in that points.py file. And so I have all that information about what a point is. But now I have this nice clean area where I can write my program. And so this is, in the real world, when you are developing Python or working with other people's object-oriented Python code, this is how you'll find it. There will be a separate file for each class, and then one file that will contain like the main function and actually run the program.
Why not have just one file that contains all of the classes? Because then I'm assuming like you have to say import and then you import all of the classes at the top.
Yeah, you could also do that. I think that, let's say I had points and lines. So it's maybe kind of nice to say I have a point file and I have a line file, and even though line doesn't exist, like I could access it like L equals line.line. Maybe I'll put it down here. If a line class existed that sort of created lines between points, we could do something like this, and maybe it would take in P and Q. So maybe this is like a line between P and Q. We don't know what it does, but if we wanted to define it, we could. And it's kind of just nice to be like, okay, point file contains the point class, line file contains the line class, and now I get this nice syntax that's like line.line, versus if I had them all in the same file, it would be like import, let's say we'll say geometry. And so geometry, if I did it this way, now it's like if geometry.py contains both class point and class line, then what am I going to have to say? I'm going to say P equals geometry.point to make a point, and let's say Q equals geometry.point. Even though we're not going to run this, I'll just put in some coordinates here. And then I might say L equals geometry.line from P to Q. And so this, you're right, like this is a reasonable thing that could be done. But it's also often the case that classes are in their own file. So both would work. And yeah.
Do you need a separate file thing? Because like if you get an error in say geometry, you have to look for it in points, lines, square, whatever. But if you get an error in like line, you know where it is.
Well, you could, if you get an error, like let's say you had your geometry file and it had both the class definitions, you would still get the line number, and so you could track it down. I guess I don't have like a great answer to like even which is done more commonly, because now that I think about it, I can think of some modules that you can download, like even ones that we'll see later in the class, like data science sort of modules that we'll use that we do access the different objects like this. And so my guess is both are done sort of like in practice. But you certainly can do them in separate files, and that's how we'll do it in this class. Okay, so that is everything that we needed to learn today to be able to do the lab. And yeah, we learned a lot. Object-oriented programming is, I think, a big topic. It's exciting. And so, yeah, I'm excited for the lab. So the plan for the rest of the day, we were going to take a quiz, an optional quiz, if you want to get more points on Practicum 1. So it'll be 15 points, and you can get up to 100. So if you get more than 100, you'll still just get 100. You don't get anything with you. And just in case, so since I said it would start at 10:05 in the announcement, let's actually take a break until 9:45, and then we'll come back and we'll have that half hour. And if anybody comes in late, I will just let them take it. But so we have a 10-minute break now. We'll start the quiz at 9:45. If you want to take it, you don't have to take it. And then we'll have half an hour for that. But if you have any questions, yeah. Otherwise, if you don't want to take the quiz,